Hello everybody, my name is Mohit Deshpande, and in this video I want to kind of give you guys an overview of machine learning. We'll talk a little bit about kind of where it came from, and I'll towards the end I just want to kind of list a few different subfields within machine learning that there's a lot of ongoing research currently going into that. So that's kind of what I'm going to be talking about in this video. So let's get started. So before we had machine learning or actually just artificial intelligence in general, AI, um, computers were very unintelligent machines, because even though they were really good at computing large numbers or performing large computations and things of that nature, even though they could do those really fast, they had to be told exactly what to do. And so I guess that's something worth writing down, is something like before AI, I mean computers had to be told, had to be told exactly, well, it's bad exactly, told exactly what to do. Exactly what to do. You had to account for every possible input or change in your machine state or something like that. You had to account for every single possibility, and that became tedious very fast, because there are cases where this becomes incredibly time consuming to have to hard code in your program all of these possible configurations or possible inputs, and that actually, that also adds to the length of your program. And so, way back then, it was just something that before AI, it's something that you just had to do, or you had to have some sort of fail-safe condition or something like that. But then, towards after then people started asking the question, instead of telling computers exactly what to do each time, can we teach them to kind of learn on their own? And as it turns out, there was a lot of stuff going around in science fiction, particularly authors and writers in science fiction were starting to depict robots, and they had like robots being kind of sentient beings, and they kind of looked like mechanical men. Was I guess what the term was, but eventually turned into robots. And then they had like all these futuristic stuff with robots, like they could greet you and shake your hand, and they just had like this repository of knowledge that they could draw from, and they were sentient. They knew that they were they knew their own existence and everything, and they learned. And that's probably the most important aspect of the thing that what AI researchers were taking from science fiction, was that robots could learn. And so then they started getting into, how can we model knowledge, and how can we get in some kind of representation with which to learn. And that kind of starts getting into this period of time when we were doing stuff called classic AI, and that was actually more centered around intelligent search instead of actual like learning. So what I mean by that is, let's suppose that we were playing like a game, like something simple that we all know. So like tic-tac-toe or something, where let's say that I am the blue circles. So I don't know, suppose I play a move like here, and then it's a computer's turn. And so then the computer has, 1, 2, 3, 4, 5, 6, 7, 8. The computer has 8 possible places where it can put an X. So what classic AI was trying to do is it will try every one of these possible combinations, and then it'll try to predict. So like if the X was put here, for example, then after that, after that X was played, then it'll try to predict what my motion is. Then like maybe it'll play something like this, and then from there the AI could do 1, 2, 3, 4, 5, 6 different moves, and so it tries each one of them, and eventually, you get this giant search space basically, where you're looking at every single possible way that the game could be played out, from the human just playing a single O here. I mean, there's so many possible combinations. And as it turns out, there are different techniques that you can actually get this working like reasonably well. You can, write an AI to play tic-tac-toe with you, and such that it will choose the best move to try to prevent you from winning. It's actually called that's called a min-max strategy. But anyway, you can build this, and it's actually not that hard to do, and it runs reasonably fast. And so this is something that you can build, but this is for something like tic-tac-toe. This is a really simple game. I mean, now imagine if we had something like chess. Well, that's wrong color there. Right? I mean, imagine if we had something like chess, where it's not just like 8 possible moves. It's so many moves. Tons and tons of moves on this chessboard. And as it turns out, I think way back in I think sometime in the mid 1990s or something, one of IBM's machines, Deep Blue, I think is what it was called, actually ended up beating the national chess champion or something similar to that. And so, trying to do this classic AI stuff with search, when it comes to like large games like chess, or even with even larger games, like there's a game, an ancient Chinese game called Go, that's often played, and it has even more configuration possible moves than chess. So at some point, it just becomes like the number of possible ways a game could be played out is so big that it would either, one, use up all the RAM in your computer and crash, or two, it just take computing all of this stuff out would take much longer than you could actually play a game with. And so search is not a good thing to to really to do in now. But back then it was the only viable option at that time. There was some dabbling going on in actual learning, but a lot of the stuff with classic AI was using search, different kinds of searching algorithms, and so you could have it to play tic-tac-toe or chess or something. But relatively recently, I should say, there's kind of been this move from, instead of search, we move towards actual learning. So we move towards actual learning. So instead of looking at all possible configurations, we start we start training an AI, we start teaching an AI by giving it lots of example data that it can draw from. And so when it gets new input data, it can intelligently, it knows because it's seen previous data, what to do with this new problem. So if you have a particular problem and you're training an AI, you give it lots of examples with that, with that problem, and then it can start learning ways that it can approach a problem. And this is all, I'm speaking in kind of the abstract sense, because I want to make this as general as possible. But as there are a lot of different subfields that I don't want to get too specific, because then it won't apply to some subfields. But right, so when we're trying to solve a problem, we train an AI, and then the AI has seen examples of this, how to solve the problem, and so then it knows, from new input, it can reason through, how to solve that problem with some new input. So that's kind of a broad level overview of machine learning, but there are actually a few, subfields within this. Like, this is machine learning itself is a fairly big field. So like, there's research, going on into, I'm sure you've heard of neural networks. I think they've been in the news at some point. But neural networks, try to take the more biological route, and they try to model what's going on in our brains. Albeit it's a very overly simplistic model, it's still a model, and it turns out that it works really well. It turns out we can also break down neural networks into things like language with recurrent neural networks, or vision with convolutional neural networks, but we can even branch this off even further. There are people researching deep learning specifically, and that's kind of related to neural networks. But with deep learning, the issue is, how deep can we make these neural networks? You know, how many layers can we go, and what kind of challenges do we encounter as we make these layers really deep? And so they're trying to find solutions for that. I mean, there's stuff going on with reinforcement learning is also pretty popular, and reinforcement learning is actually used. I guess it's very popular to use for teaching AI to play games. Actually, I think there's a. If you look around, there's an AI that can actually play like the original Mario, Super Mario Bros. Or something like that. They can play they can play through the original Mario game, and reinforcement learning kind of helps let you build that kind of model. I think they can also play like they've built reinforcement learning models that can play like asteroids and a ton of the old like Atari games like fairly well too. So right, I mean these are just some of the subfields. I can't possibly list all of them because it's a really big field, but I'm just going to stop right here and do a quick recap. So with machine learning, before AI, computers weren't very intelligent. You had to tell them exactly what to do, and this became like impossible in some cases because you can't think of all possible configurations or inputs that you can get. And so this is when we start getting into classic AI. But even with classic AI, we were technically just doing searching. We weren't actually learning anything about this. And now we've moved from search more to learning, and where we actually are learning of knowledge representations and using those. And I just mentioned a couple subfields of machine learning here, with neural networks, deep learning, and reinforcement learning to kind of show you that this is a very popular field at this point, and it's a very, very rapidly expanding field, and you can definitely expect many more cool advances to come in the future.